Hey, welcome to this video. This is Mr. Maestas, and I will be doing a, excuse me. In this video, I'll be doing some problems that are on my midterm number 3 review for the Math 1600 course. This is statistics, and we're looking at the first part of inference. So, if you're not in my Math 1600 course and you just want some practice problems here for me to go over on inference, I'll be going over sampling distributions, looking at one sample hypothesis test for means, and one sample hypothesis test and confidence intervals for proportions, and then two sample confidence intervals and hypothesis tests for proportions. So that's the video. Well, that's part of the videos. I'm actually going to have to do this in parts because the program that I'm using to record this only allows me 15 minutes, and I really think it's going to take me more than 15 minutes to go through all of these problems. Okay, so I'll cut this in about 15-minute increments. I'll probably do a couple of problems each one, and I don't know quite yet because I haven't started how many parts this will take, but I'll label them as different parts. So let's look at problem number 1. An airline computes the capacity and range for its planes using a normal distribution of weights for adult passengers with mean of 150 pounds and a standard deviation of 20. So that we know already is our population, right? So this is our mu. So let me grab my pen here. So we know that mu is going to be 150 because that's our population mean. It's given right here. And our standard deviation, our population standard deviation, sigma, is going to be 20. I'll just label these, okay, with units. So if I was going to draw my normal model, right in the middle here, I would have 150 pounds, and then I would subtract 20 each time to give me 130. Then 110, then 90, add 20, 170, 190, 210. Okay, so this would be what my normal model would look like because I'm going up and down 20 for each of my standard deviations. So let me answer this question here. It says, what is the probability that the mean weight of a group of 100 passengers will lie between 151, right here, and 153? Well, this normal model works for this population distribution, but I'm talking about a sample of 100 passengers. So really, I want to draw a sampling distribution. Okay, so I need a sampling distribution. And in a sampling distribution, I need to make sure that I know that my standard deviation is going to be sigma over the square root of n. So I'm going to go ahead and calculate that out. Sigma being 20, n being 100. And I'm going to get 2. Okay, so that's my S. Okay, so what I need to do is I really need a sampling distribution is 150, and then 148, and 146, 144, 152, 154, and so on. You see, I'm adding S there, and this is still my mean. Okay, so I'm looking at between 151, it's right here, and 153, it's right here. So this shaded area. This is a normal model also. All right, so what I'm going to have to do is I'm going to have to find z-scores. Okay, so let's go ahead and find the z-score. The z, let's see here, pen's not working. The z is going to be x bar minus mu over S for a sampling distribution. So we're going to go ahead and do x bar, we're going to do both of them. So 151 minus mu, which was 150, over s we found was 2. And that's going to give me 1/2. I like them in decimal here. And my other z is x bar minus mu over s, which is 153 minus 150 over 2, which gives me 3/2, which is 1.5. So I'm looking for the probability that z is between 1.5 and 0.5. So I'm going to have to look that up in my z table. So let's go ahead and go to our z table, and here's our z table. So now my z scores are 1.5. Let me zoom in here. All right, so we've got 0.5 right here. And remember that this table right here is giving me all the values that are lower than z, right? So I want to find 1.5. I want to find that value, and I'm going to subtract it from the value of 0.5, and that should give me the value in between. So 1.5 is 0.9332. So 0.9332 minus the value, the p score, the p probability, when I have a z-score of 0.5. So that's going to be 0.6915. 0.6915. And I'll use my calculator. That gives me 0.2417. So that's going to be 24.17%. Is my probability that the mean weight of the group of 100 passengers will be between 151 and 153. All right, so this is a sampling distribution problem where we're using a normal model. Let's take a look at the next problem. Man, it's going to take me forever. Lots of videos if it's 7 minutes each one. And that wasn't even a hypothesis test. Okay, in a study of a textbook costs a random sample of 120, so we can already label that as n. Were surveyed yielding a mean expense, so that's mean of 124, and a sample standard deviation of 15. So we've got x bar, which is 124, and s, which is 15. And we're dealing with a sample, right? So this seems like we're going to be doing some sort of inference with a confidence interval or a test. Construct a 99% confidence interval for the true mean expense, and we're going to interpret the interval in context. So let's do A first. So we're going to construct the confidence interval. The interval is x bar plus or minus the margin of error. And we know the margin of error is going to be z star times the standard error of x bar, which is standard error is in this case is going to be s over the square root of n. Now we're using z star because our sample size is large. It's 120. So we can use z. If this sample size was less than 30, we would want to use t distribution. All right, so we're going to use our z. Sorry. And our z star for 99% confidence is going to be 2.575. So I'm going to write that z star. Okay, so let's do this all together. So x bar is 124 plus or minus z star, which was 2.575, times s, which was 15, over the square root of n, 120. Now, don't forget that we need to have our conditions here for inference, and I'll do that for B because it's a hypothesis test, and I want to write all those parts out for you. Right now, we'll just do the work for the confidence interval. So 124 plus or minus, we'll enter that in our calculator. We'll get 3.526. So we'll do 124 plus 3.526, 124 minus 3.526, and remember that the plus one is going to actually go second. I don't know why I put that there, but the plus one's going to go second. Okay, so let's switch these around here. 127.526 and 120.474, and there's our confidence interval. So how do we interpret that? Well, we'll go ahead and say that we are 99% confident that the true mean expense of textbooks is between $120.47 and $127.53. All right, so that is our confidence interval in context. All right, so let's look at number letter B. This one will be the last one that I do on this video, and then I'll start the next one on the next video, okay? So we're going to use a test whether the true mean expense is less than 128. So the first thing we do is write our hypothesis. So our null hypothesis is going to be that mu of textbook costs, so I'm going to put C, is equal to 128. Now some textbooks will say greater than or equal to because our alternative here is less than 128, okay, because that's what we get from here. But I like to go with the equal sign, so I'm going to go and stay consistent and go with the equal sign. This would be the first thing we do. Now the second thing we do is we need to have our conditions for inference. So what are our conditions for inference for means, for one sample means with a large sample size? Well, the first thing is that we have a random sample. So we just want to make a note that our sample is taken at random. Second, we want to say that 120 students is less than 10% of all students. Finally, we want to say that these come from a distribution that is relatively normal. So we're just going to assume that, okay? So go ahead and assume that the distribution is unimodal and symmetric. We don't know that, but that's the best we can do in this case because I didn't identify if it was. All right, so now we're going to continue with our mechanics. And in our mechanics, we're going to find our z-score and our p-value. Okay, so we're going to say our z is equal to, excuse me, 128 minus, sorry, 124 minus 128 over s over the square root of n. Excuse me, I got a little bit of cough here. 15 over the square root of 120. And that'll be our z-score. So we're going to get negative 2.92. So we want the probability that z is below negative 2.92. So we're going to go to our z table. Negative 2.92 is right here, which is 0.0018. So 0.0018 is definitely less than our alpha level. So since our p-value is less than our alpha level, there is sufficient evidence to suggest that the true mean is less than 128. We're going to reject the null hypothesis. Okay? So this is the end of part 1, and I'll start the other ones on the next video.